All right, let's look at this last page of multiplying and dividing. So we've got another word problem here. We've got 35.5 yards of material. We're making towels, and each towel requires 3/8 of a yard. So I kind of in my head visualize I've got all this material, 35.5 yards laid out, and I start snipping away towels out of it. So if I keep snipping away over and over again, that's repeated subtraction. I keep taking something away. Well, repeated subtraction is division, just like repeated addition is multiplication. So I'm going to work this as a division problem. In theory, you could work it as repeated subtraction, but I'll go ahead and kind of give you a spoiler. We can make 94 towels. So you would have to subtract 3/8 94 times, and I don't think we want to do that. So like we've been seeing before, we need to change this to a mixed number, and then we're going to divide. So I'm going to ask that you pause and give yourself some more practice with changing that mixed number and then also with that division step so that we can get that. So go ahead and pause and see how far you can get. Coming back from the pause, I would multiply 35 times 2. So that 35 times 2 gives me 70. So that'd be 70 halves, and add the 1/2. So I get 71 halves. So I want to take that 71 halves and I want to divide it by 3/8. And remember, our rule is to keep, change, flip. So I kept, changed, and flipped. So 71 times 8, multiplying across the numerator, multiplying across the denominator, and then I'm going to reduce that down. That gives me 2/84 thirds. Now I want to know how many whole towels I can make. I don't want this part of a towel. So 284 thirds is 94.6666, a whole bunch of 6s and 7s. So that means I can make 94 towels. And I don't really care about that leftover 666 in part A. I just want to know how many towels can be made. So that's that whole number part of the problem. Whole towels. B asks me how much material will be left over. Now notice part A asks about towels and part B asks about material. So I do need to keep those numbers straight. So to figure out how much is left over, I know I use 94 whole towels. So 94 times 3, because that's what my denominator gives me, is 282. So I'm going to think about 284 thirds, changing it to a mixed number. So I'm going to change that numerator to be, instead of 284, I'm going to do 282 plus 2. Remember, to change to that mixed number, we want to get a multiple of 3 as close as we can to 284. Well, I didn't know what multiple of 3 is closest to 284. I don't know my multiples of 3 that much. That's why I did this kind of like shortcut thing over here, where I used my answer from before and the denominator to help me figure out that multiple. So now, 284 is the same thing as 282 plus 2. I can split this up into 2 fractions. 282 thirds is 94. And there's that 2 thirds. That's what's left over. Now, up here, I wrote out a decimal. Some people might recognize that 0.666667 is 2 thirds. So that's the 94. And then, so we've got the 94 and then the 2 thirds. You need to rewatch that. Go ahead, rewind it and rewatch it. This isn't actually the final answer. It's just kind of like a little stopping point. But feel free to rewind. This 2 thirds was how much was left over of a towel. 2 thirds of a towel was left over. The 94 and 94 whole towels and 2 thirds of a towel. Each towel is 3/8 of a yard. That's from my directions up top. So I'm going to multiply. Multiplying across the top is going to give me 6. Across the bottom is going to give me 24. And that reduces to 1/4 yards. The reason I have to multiply there is what I was mentioning earlier. That's because the 2/3 is the amount of a towel, 2/3 of a towel. And I wasn't asked how much of a towel was left over. I was asked how much of a yards were left over. So I had to take that towels and multiply it by the number of yards that were in each towel to get that final answer. All right, so that kind of finishes up our word problems. We do have a few more exponent rules to go over down here. We will add these to the ones we already know. These do have to do with division. So one thing we might not have seen before is a negative exponent. A negative exponent is just kind of a way to write an exponent that would be in a fraction. So a negative exponent means it would be found in really the opposite place. So in my example, it was in the numerator. So the negative exponent means the opposite, that inverse. We're used to that -3 being the inverse of 3. So the opposite of the numerator is a denominator. We've seen one kind of similar to this rule when we were dealing with just two terms. It's not a set of parentheses. Now we've got a top and a bottom, but the exponent would relate to both of these. So kind of putting that together in this last one, both the numerator and the denominator would get a negative exponent. And like I was just saying, negative means that inverse. We want it to be in the opposite place. So what was in the denominator goes to the numerator, and what was in the numerator goes to the denominator. And when we move it, if you notice, both of these, when we move them, we end up with a positive exponent. So as soon as you move it to its opposite place, you no longer need that negative. So let's see these put into action down here. I only need to move the negative exponents. So I'm going to keep the 3 to the 4th in the bottom. And I'm going to move that 3 squared to the bottom as well, to the denominator. When I move it, I get a positive exponent. There's nothing in the numerator, so that's my invisible 1. And then I remember from before that we add those exponents together. And I'm going to leave it with positive exponents in my final answer. So I can just leave it as 1/3 to the 6th. I'm not going to type in and see what 3 to the 6th is. Looking at B here, kind of a throwback. In the numerator, that's where we're going to multiply those exponents. I need to move this -5. It's going to move to the numerator. It's that inverse. That leaves me nothing in the denominator. You can put a 1 there if you want to. You don't have to though, because we can simplify that. And then I'm going to add the exponents together to get x to the 11th. And this last one doesn't have a negative exponent, but it has to do with that. Making sure we go to the numerator and the denominator. And then remember that 1 to any power, it doesn't matter how big it is just 1. So I am going to reduce that down. But again, I'm going to leave 3 to the 12th power because my directions said I could leave that positive exponent.